Good morning, students. Today we describe the implementation of AND function using perceptron network for bipolar input and targets. Okay, so let's start. What is bipolar input and what is bipolar target? First, we discuss the part that is the perceptron network, which uses perceptron learning rule, is used to train the AND function. So first of all, we define the truth table of AND function in the terms of bipolar input and bipolar targets. Fine. So here we consider two input AND gate, that is x1 and x2, and here T stands for the target. Okay. So for the two input AND gate, so what are the basic inputs? That is, we know 1 0 1 0 1 1 0 0. But in case of the bipolar input and targets, in case of the bipolar input also, we replace the 0 in terms of -1. That is, now the bipolar input become 1 minus 1 1 minus 1 1 1 minus 1 minus 1. Actually here 0 is replaced with -1. And what is the t? T is our actually target output. So we know in case of the AND function, if both the cases are true, then the output will become true. So therefore when x1, the value of x1 is equal to 1 and the value of x2 is equal to 1, then the target output will become 1. But when the x1 become 1 and x2 become -1, then the target output will become -1. And the same case will be for the -1 1 also and -1 -1 also. So the target output for the AND function, that is in terms of the bipolar input, that is 1 -1 -1 and -1. Okay, so this is basically the truth table of for AND function in case of the bipolar input. Now we set some weights here, that is w1 and w2 for the x1 and x2 functions. What is the w1? The initially we treat w1, w2 and b is equal to 0, and theta is the threshold that we also set to 0. And one important thing, that is the learning rate alpha, we set the value of alpha initially as 1. Okay. Next, we just draw the perceptron network for the AND function. So here we consider two inputs, that is x1 input and x2 input. So here this is the x1 part, this is the x2 part, and this is the bipolar or the bias part. And these all parts are connected to a function that is equals to y. And ultimately the output will become y or y in. We'll explain it later in the next slide. Okay. So in the x1 part, we put or we input the x1 as in the x1 part, and what will be the output? That is the w1. So for the x1 part, we consider one x1 input and another w1 weight. And for the w2 and for the x2, we use x1, if we use x2 as the input, and we also use w2 for the weight for the x2 part. So next, for the first input pattern, that is x1 is equal to 1 and x2 is equal to 1 and t is equal to 1. If we go through the previous slide, that is the truth table, the first row of the truth table, x1, x2 and t, here we have seen that x1 value is 1, x2 value is 1 and t value is 1. Therefore, we consider the first case, that is x1 is equal to 1, x2 is equal to 1 and t is equal to 1 with the weights and bias w1 is equal to 0, w2 is equal to 0 and b is equal to 0. That we also established initially. So what is our net input? That is our net input is y in. Y in is our net input. That is this part. This is our net input y in. Okay. So what is the value of y in? As per the law of the Hebb network. Okay. So what is the value of y in? Y in is equal to b plus x1 w1 plus x2 w2. So initially the value of b we treated as 0, and the value of x1 is equal to 1, that is we replace here 1, and value of w2 is equal, w1 is equal to 0, so we replace what 0. So x1 w1 will become 1 into 0, that is 0. And again similarly x2 w2 is equal to 1 into 0, that will also 0. So the summation of whole give us 0. Now one more important thing to understand, that is what is the output, that is the y is computed by the applying activation function. So what is the activation function? That is after calculating the y in value, that is, this is my y in value, that is b plus x1 w1 plus x2 w2. So first we calculate the y in value, then we put the y in value in the activation function. If we have seen that the value of y in is equal to more than 0, if the value of y in is equal to more than 0, then the value will become 1, and if the value of y in is equal to 0, then the value will become 0, and if the value of y in less than 0, then the value of y, that is the activation function, will become -1. So here we treat three cases: when y in greater than 0, y in is equal to 0, and y in less than 0. So for if it is greater than 0, then 1; if it is equal to 0, then 0; if it is less than 0, then -1. This is our activation function. Okay. So next slides, that is, in this slide we compute the value of w1, w2, and b. Okay. So what is the basic formula of calculating the w new value? That is wi new value. The formula of wi new is equal to wi old plus alpha t xi. So here we know t is our target output, that is it always 1. Our target output is always 1. Okay. It always 1, or it can be -1. Okay. So if it is 1, then it is true, and if it is -1, then that means it is false. So the formula of calculating the w1 new is equal to w1 old plus alpha t into x1, that is 0. What is the w1 old? Initially we treat w1 as 0, and then alpha is equal to, we set 1. We discussed it in our previous slides. And what is the t for this? T for the first row, t is equal to 1, and what is x1? That is also 1. So initially w1 is equal to 1, and also w2 is equal to 1, and b is equal to 1. So initially all the values are 1. Okay. So this is the way we calculating the w functions. So the way w1 is equal to 1, and w2 is equal to 1, and b is equal to 1 are the final weight after first input pattern is presented. The same process is repeated for all the input patterns. Means we apply for the w1 and w2 for the next input pattern, that is 1 minus 1. That is when x1 is equal to 1. That means when x1 is equal to 1, and x2 is equal to 1, and t is equal to -1. And the third case will be x1 is equal to -1, x2 is equal to 1, and t is equal to -1. And the fourth case will be x1 is equal to -1, x2 is equal to -1, and t is equal to -1. Okay. So we need to consider all the cases here. So now we compute this table. This is very important. This is basically the perception table, and we need to understand the whole fact of this particular table. So let us start to describe this table. Now first we take the inputs. Actually here what is our input? That is x1, x2, our input. Okay. x1, x2 is our input, and the value of b we treated as 1 in all the cases. Okay. And what is our target? Target is the output or the bipolar target for the n function. We know the inputs for 1, 1 is equal to 1, and all other cases the target output for the target output for the n function will be -1. Okay. So this is clear. Next, what is the net input? That is y. We need to calculate the net input. Then after calculating the net input, based on the net input, we calculate the target output, that is a calculated output by using the activation function. Okay. Next we calculate the weight changes that we have shown in our just previous slides. That is del w1 means the new weight, del w2 means the new weight for w2, and del b is the new weight for the b, that is the bias. And this is the initial weight w1, w2, and b. Initially we treat w1, w2, and b is equal to 0. Let us start the functions. So initially we know w1 is equal to 0, w2 is equal to 0, and b is equal to 1. And what will be the next w1, w2, and b value? The next value of w1, w2 is b is 1, 1, 1. Actually, the next value of w1, w2, and b is equal to 1, 1, 1. Actually, this calculation we have shown in the previous slides. That is, if I consider this part, that is initially it is what? 0, 0, 0. That is w1. That is w1 is old is 0, w2 old is 0, and b old is 0. That is 0, 0, 0. And w1 new is equal to 1, w2 new is equal to 1, and b is equal to 1. So initially w1, w2, b is equal to 0, 0, 0, and the next changes input, the next changes value of the w1, w2, and b are 1. So here we just write del w1 in 1, del w2 in 1, and they will be also 1. Next, we just compute the values of these both. Okay. In the next slides, we have seen that the value is -1, 1, and -1. We apply the same rule over here, and in the third case, this will be 1, this will be -1, and this will be -1, and the fourth case, this will be 0, 0, 6, 0. Next, how we calculate the weight functions? We just sum up this value with this value. Say this is the 1, this is the W1, that is the old value, and this is the new value, that is 1 minus 1 give us 0. This is 1 and this is 1 give us 2, and this is 1 and this is -1 give us how much? 0. Similarly, we use the third case also, that is 0 plus 1, that is 1, 2 plus -1, that is equals to 1, and 0 and -1 give us -1, and then 1 plus 0 is equal to 1, 1 plus 0 is equal to 1, and -1 plus 0 is equal to -1. Okay, so we have computed this epoch. Now we calculated this value. This value is very important for calculating. That is, first of all, what is the value of W1, W2, and V? That is 0, 0, 0. And here, what is the value of X1, X2? That is 1, 1. So what is our formula? That is B plus W1 X1 plus W2 X2. So 0 plus 0 into 1, that is 0, and 0 into 1, that is 0. So it will become 0. In the next phase, that is, what is the value of W1, W2, and 1? That is 1, 1, 1. So in case of B is equal to 1, so 1 plus 1 into 1, that is 1, and 1 into -1, that is -1. So 1 minus 1 cancelled, and 1 is here, and 1 is given seat. So the value of y is equal to 1. Next, 0 to 0, that is 0 into -1, that is how much? That is 0. 2 into 1, that is how much? 2. And 0 into 1, how much? 0. So the value will become 2. Again, this for the 1 into -1, that is -1. 1 into -1, that is -1, and -1 into 1, that is -1. So it will become -3. Next, based on the net input, we calculate the calculated output of the activation functions. Let us go through the previous slide. That is, here we consider if the y value is greater than 0, then it will 1. If the value is equal to 0, then this is 0, and if the value is less than 0, then it will be -1. Let us start. That is, the value is become 0, so the value is 0. Value will become 1, so value will become more than 0, so it will become 1. Value will become more than 0, so it will become 1, and value will less than 0, so the output value will become -1. So this is the calculation of the first epoch. Next, we come to the second epoch until our weight changes become 0. So let's start. So again, for the epoch 2, we write down the same input pattern for the n function. So these steps are same. Okay. Next, we calculated the weight changes and weight. Then based on the weight changes and weight, we calculated the net input and the calculated output. Okay. So first of all, what is our net changes? That is, what is our last weight? That is 1, 1, and -1. And what is our last updated weight changes? 0, 0, 0. So ultimately, if it is 0, 0, 0, then what happened over here? That is the same reason is there. So 0 into 1, 0, 1 into 0, 0, and -1 into 0, that is 0. So in all terms, it will become 0, and this value will replace same, because we know the calculation of weight, that is 1 plus 0 is equal to 1, 1 plus 0 is equal to 1, and -1 plus 0 is equal to 1. So in all cases, if the pattern will be 1, 1, -1. So here also 1, 1, -1, and here also 1, 1, -1. Next, come into this part, that is how to calculate next input. That is 1 into, we know the same fact, the same way we use here in the epoch 1, we use the same fact in the epoch 2 also for calculating the y in and y. Okay, so that is what? That is 1 into 1, that is how much? We know here, that is here 1 into 1, that is 1, 1 into 1, that is 1, and -1 into 1, that is -1. So the value will become 1. Next, that is 1 into 1, how much? You know, that is 1 into 1, 1, 1 into -1, -1, and -1 into 1 is equal to -1. So it will become how much? It will become -1. Okay. Next, 1 into -1, that is -1. Next, 1 into 1, that is 1, and -1 into -1, that is -1. Okay. Next, 1 into -1, -1. Next, 1 into -1, -1, and -1 into 1 is equal to -1. So -1, -1, -1 give us -3. So based on this figure, that is value is big, 1 is less than 1 is equals to 1. It is 1, that is more than 0, so it is 1. it is less than 0, that is -1, less than 0, -1, less than 0, -1. So we stop the process here for the AND function because our weight changes will become 0. If we go through the next epoch 3, then the same input and same output will be generated. Okay. So next part, that is we calculate the functions. Okay, that is target and calculated output convert for all the patterns here. So finally we know that is what is our w1, w2 and b, that is 1 1 and -1. Okay, so the formula of calculating the line function, that is x2 is equal to minus w1 by w2 x1 minus b by w2. So we know the formula, that is w1 x1 plus w2 x2 plus w greater than always theta, and we set the value of theta, the threshold value of theta, that is 0. So it will become, of course, greater than equals to, that is greater than 0. So what is the value of x2 and x2? That is the x2 will become minus 1 by 1, x1 minus -1 by 1. So the ultimately equation will be x2 is equal to minus x1 plus 1. That is x1 plus x2 is equal to 1. So we have shown these diagrams in the next slides. That is, here we consider the a diagram, that is the graphical chart over here. That is, we consider here x-axis as x1 and y-axis as x2. Okay, so next this will become 1 1 point, this will become -1 -1 -1 1 point, that's the second quadrant, and this will the third quadrant, that is -1 -1, and this is the fourth quadrant, that is 1 -1. Fine. So we here draw the line function of x1 plus x2 is equal to 1, or that is x2 is equal to minus x1 plus 1, that will become x2 plus x1 is equal to 1. Okay, so this is basically the line function for the AND function. So this is the actual block diagrams and also the graphical diagrams with the calculated input and calculated output for the bipolar functions for implementation of AND function. Thank you all, students.